Have you ever stopped to think that, even after centuries of study, we still know very little about the solar system? What seems so familiar, the shining sun, the moon lighting up our nights, and the planets we memorized in school, actually hide secrets most people have never heard of. Some of these secrets could even change the way you see the place you live. Want to know what the books didn't tell you? The solar system formed about 4.6 billion years ago from a giant cloud of gas and dust called the solar nebula. This cloud began to collapse under the force of gravity, concentrating most of its mass at the center, which gave rise to the Sun. The remaining material around it started clumping together into larger and larger pieces, eventually forming planets, moons, asteroids, and other celestial bodies. This process is known as planetary accretion. The composition of the solar system is diverse. The planets closest to the Sun, Mercury, Venus, Earth, and Mars, are called rocky planets because they have solid surfaces and are mainly made of iron, nickel, and silicates. The more distant planets, Jupiter, Saturn, Uranus, and Neptune, are known as gas and ice giants, composed mostly of hydrogen, helium, methane, and ammonia. In addition to planets, there are also dwarf planets, asteroids, comets, and billions of small fragments orbiting the Sun. Altogether, the solar system is like a natural laboratory. By studying its formation, scientists not only learn about the origin of Earth but also how other planetary systems may have developed in the universe. It's like investigating the roots of our own existence. And to better understand this structure, we need to take a closer look at its central piece, the Sun, the star that keeps everything united and in motion. The Sun is a star located at the center of the solar system and holds about 99.8% of its total mass. Its gravity keeps the planets, moons, asteroids, and comets in orbit. If the Sun were to disappear, all these bodies would drift off into space without direction. This gravitational force is what keeps the solar system stable and organized. Beyond gravity, the Sun is the main source of energy for Earth. It produces light and heat through nuclear fusion reactions in its core, where hydrogen turns into helium. This energy makes climates, oceans, photosynthesis, and the cycle of life possible. Without the Sun's energy, Earth would be a frozen, lifeless planet. The Sun also influences its surroundings with the solar wind, a stream of charged particles. This wind can affect satellites, communication systems, and even generate auroras on Earth. It shows that the Sun is not just a lamp in the sky, but an active force regulating almost everything within the solar system. The solar system has 8 planets, divided into 2 groups. The 4 closest to the Sun, Mercury, Venus, Earth, and Mars, are called rocky planets because they have solid surfaces and smaller sizes. Mercury is the smallest and closest to the Sun, Venus has an extremely dense and hot atmosphere, Earth is the only planet known to support life, and Mars stands out for having evidence of water in the past. Farther away are the gas and ice giants, Jupiter, Saturn, Uranus, and Neptune. Jupiter is the largest planet, so massive it could fit more than 1,000 Earths inside. Saturn is famous for its spectacular rings made of ice and rocks. Uranus rotates on its side compared to the other planets, and Neptune, the farthest, is known for its incredibly strong winds, the fastest measured in the solar system. Each planet has unique features that help scientists understand how the solar system formed and evolved. Studying Mars, for example, may reveal whether life ever existed outside Earth, while analyzing the atmospheres of Jupiter and Saturn helps scientists learn how giant planets form in other systems. Besides the planets, the solar system contains a wide variety of smaller bodies. These include dwarf planets such as Pluto, Ceres, Haumea, Makemake, and Eris. They orbit the Sun and are nearly spherical but don't clear their orbits of other objects. Pluto, for example, was reclassified as a dwarf planet in 2006 for this reason. moons are also fascinating. They orbit planets and vary greatly in size and composition. Earth's moon is the most familiar, but far from unique. Jupiter has over 90 moons, including Europa, which hides a salty ocean beneath its icy surface. Saturn has dozens of moons as well, with Titan standing out for its lakes of liquid methane and complex chemistry. Asteroids and comets are equally important. Most asteroids are found in the asteroid belt between Mars and Jupiter, while comets are icy bodies that develop glowing tails when they approach the Sun. These small objects are like leftovers from the solar system's birth and help scientists understand what materials were present in its early days. One of the most striking aspects of the solar system is the atmospheres of its planets. Venus has an atmosphere so dense that it causes a runaway greenhouse effect, making it the hottest planet, with temperatures above 860 degrees Fahrenheit 460 degrees Celsius. Mars has a thin atmosphere that can't hold heat, causing freezing nights. In Jupiter and Saturn, hydrogen and helium-rich atmospheres host massive storms, like Jupiter's Great Red Spot, a storm larger than Earth itself. Geological formations are also remarkable. Mars has Olympus Mons, the tallest volcano in the solar system, 3 times higher than Mount Everest. Some moons like Europa, Jupiter, and Enceladus, Saturn, have subsurface oceans hidden beneath ice layers, which could be potential habitats for life. These discoveries guide space missions searching for extraterrestrial environments. The presence of water is another key point. It's not limited to Earth. Frozen water exists on Mars, in craters on the Moon, and in several outer moons. Since water is essential for life as we know it, finding it elsewhere raises the possibility that life might not be unique to Earth. These details highlight how every celestial body has something valuable to reveal. Every object in the solar system plays a role in helping us understand our existence. Earth is studied as a reference for identifying similar planets beyond our system. Mars is investigated for its past potential to host life. Moons like Europa and Titan are prime candidates in the search for environments where life could emerge. The giant planets also matter greatly. Jupiter's massive gravity likely protected Earth by deflecting asteroids and comets that could have caused catastrophic impacts. Saturn, with its stable rings, shows how particles of ice and dust can remain organized for billions of years. These planets provide insight into the formation of other planetary systems across the galaxy. Even the smallest bodies, like asteroids and comets, act as time capsules. They preserve material that hasn't changed much since the solar system formed. By studying them, scientists learn what ingredients were present at the beginning and how they may have contributed to the emergence of life on Earth. Each object, no matter its size, is a crucial piece of the solar system's story. After all this, the big question is, what will you do with this knowledge? Will you keep looking at the sky as just a pretty backdrop, or will you see it as a living manual about who we are and where we came from? If even the smallest asteroids have something to teach, imagine how much more we can learn when we combine curiosity with science. So tell me, which part of the solar system caught your attention the most, the giant planets, the mysterious moons, or the immense power of the Sun? Share your thoughts in the comments, I'd love to hear from you. And don't forget, subscribe to the channel and turn on the notification bell, because there are still many more cosmic mysteries for us to explore together.